Are we okay?
Yes, sir.
Looking at the definitions of let me say equation is very, very much important. You know why? Because it's a guide. Okay? Some people can say, well, when you are teaching mathematical topic here, and you start with a definition, it is baseless. No, it is not baseless because that is a guide. Yes. It's a guide for you to solve the problem. Now, so when we talk about an equation here, you know what's an equation, right? Huh? Oh, okay, we don't know what's an equation, but we have done an equation, right? So when you say equation, on the pre-calculus here, we have an equation here. Whenever that was an equation here, one thing that you must look out for is what is an equal sign. And you guys call this guy as what? As an equal to sign. It is not an equal to sign. It is what? An equal sign.
Equal sign.
Mind you, we have what we have equal to, we also have what we have equal, right?
Equal, yeah.
So when I ask you, what is an equation? What's an equation here? An equation here is what? Is a mathematical statement that has what? That has an equal sign. Okay? An equation is what? Is a mathematical statement that has what? That has an equal sign. Right? So therefore, what you must look out for in any expression is what? Is this equal sign. Alright? Mind you, we have an expression, we also have an equation. An expression is different from an equation. An expression can have all the attributes of what? Of an equation, but what happens now? They fail to have what? To have what? An equal sign. Are we alright?
Yes, sir.
Or we can say again. An equation is what? Is where we have what? Two expressions separated by what? By an equal sign. Whenever you have what? You have two expressions. And you have what? You have an equal sign that is separating the equation, the two expressions here. Then we say we have what? We have an equation. Right? Or you can say what? An equation is what? Is any mathematical statement, right? That is separated by what? By an equal sign. Are you right here?
Yes,
good. Now this case here, one that we must always note again. For every equation here, there must be what? There must be what? A coefficient. There must be what? Also we have what? We have a variable. Also we have an operations. We also have what? We have a constant. Are we okay? For every equation or expression here, what happens now? We have what? We have a constant. We have a coefficient. We also have what? We have a variable, and we have the operations as well. What are they? What is a coefficient here? A coefficient here is any number that stands in front of the variable. Alright? Okay, let me just tell you what a variable is. A variable here is what? It's a letter or symbol that stands just after a number. Are we okay? Yes. So that's the case now. Looking at this guy here, this guy is a letter, right? Yes. Any letter or number that stands just after a number is what? Is any letter or symbol, that stand just after a number is called what? Is called a variable. So therefore x here is what? Is a variable. Okay? It's a variable. So a variable can be what? Can be a symbol. Why are we saying what symbol? Why are we making mention of symbol? Because it can be, we can have a theta, right? We can also have what? Alpha. We can have what? We can have beta. They are Greek alphabet, but we refer to them as what? As a symbol. Are we okay?
Yes, sir.
So that right here, we say what? We say a variable can be what? Can be a symbol, or a variable can be what? Can be a letter. So wherever you see what? You see a letter in any mathematical expression or equation, that letter or symbol is called a variable. Are we right? Yes, so now, what is a coefficient? A coefficient is any number that is standing in front of a letter or symbol in a mathematical expression or equation is called what? Is called a coefficient. Any number that stands in front of a letter or symbol in a mathematical expression or equation is called what? Is called a coefficient. Are you okay?
Yes, sir.
You must understand these things because these are the things that you are going to look out when you are solving the problem. Are you okay? So now we know what is a coefficient, And also we don't know what is a what. What is a variable, right? Now what is a constant? A constant here is what is any number that stands without any attachment of what, of a letter or symbol as well. Alright? A constant is any number in a mathematical expression that stands alone without what, any attachment of a letter or symbol. So therefore, if you look at this guy here, this guy is what, is a number, right?
Yes,
and this number here is what is standing alone. It can be what? It can be before the equal sign, and it can be also after the equal sign. Alright? But what you must have into consideration here is what? A number that stands alone without any attachment of a letter or a symbol is called what? Is called a constant. Or you can say what? A constant is any number in a mathematical expression that stands without a variable. Because remember what is a variable, right? You say a variable is what? Is any letter or symbol that you have in what, in the mathematical expression, right? Good. How this one is clear, right? Now what about the operators here or the operations? What are they? The plus sign, the minus sign, even the equal sign is what? Is an operator, right? They are what? They are what we call as the operations. Because without these guys, we cannot have an equation. We cannot have an expression, right? Because they come together here when you solve the problem. Is that so, sir? We have 2x plus what? Let me just say plus 1 here. Again. Alright? I'll say 2x here is equal to what? Is equal to 0. But one thing I want you to take into consideration again. We have what? You have the inverse of signs here again. What are they? Multiplication and division, they are what? They are inverse. Are we getting this concept here?
Yes, sir.
Multiplication and division, they are what? They are inverse. What are they? Now we have what? We have division here, and we have what? We have multiplication. In terms of equation here, we see the multiplication and what? And the division, they are what? They are inverse. Now what is an inverse, right? Example here. If you are asked to find the value of what? Of x or y, you know what happens here? That comes in. Mind you, if you have x here is equal to what? Is equal to 2. This man, is it a variable here? Do you have a variable?
No.
Yes, we have a variable, right?
Okay,
because we say a variable is what? Is any letter or symbol that we have in a mathematical statement, right? So therefore, this man is a letter, and wherever we see a letter, that letter is called what? It's called a variable, right?
Yeah.
So therefore, this variable is equal to what now?
2.
It's equal to 2. Alright? Now you can say equal to. That means this man and this man, they are the same. That's what was equation. When you solve the problem, what you have been asked to find after you have gotten the answer of that particular variable. Now when you substitute into the original equation, if the answers are not the same, if the right hand side and the left hand side are not equal, it means your work is not correct. Look at what equation, right? This sign is telling me that what you have on the right hand side and what you have on the left hand side, they are equal. Are we okay, sir?
Yes,
so always, whenever you are asked to find a variable, you know what that means? It means that variable, that symbol, that man must stand alone, right?
Yes,
that means it must have a coefficient of 1. Now, in this case here, we have a coefficient here, but this coefficient is 1, right? So therefore, this means that we have gotten our variable here, which is what? Which is 2, right? That's the value of this particular variable. But how can we achieve this one? Mind you, if we say 1 times x is equal to what? Is equal to 2, right? What is what we have? You can say what 1x, right?
Yes.
But this one is what is unprofessional. We cannot indicate the 1. Always, whenever a variable is standing alone without seeing a number here, not that there is an attachment of just 1. When it is more than 1, we can indicate, right? Good. Now, not that if we have 2 multiplied by x is equal to what? We say it's equal to 2, right? Now 2 times x, what do you have?
2x.
Now we have 2x here is now equal to what? Is equal to 2. Are we alright? Now but come on here. We are being asked to find the value of x. How can we achieve that one? We can only achieve mind you. What are we doing here? We are multiplying, right? Are we multiplying here?
Yeah.
Here comes the inverse, which I was explaining about. Now we say multiplication and division. In terms of equation, there was the inverse, right?
Yeah.
Now that means for us to make this man to stand alone, what do we do here? We divide. And how do we divide here? Well, that is what 2x here divided by what? By 2. That is the coefficient that is what? That's closer to what? To x. our aim here is to want is to make the coefficient of what to be 1, right?
Yes, sir.
Now, the only way you can achieve this one here is by what? By dividing the coefficient so that is closer to what to x. That is the only way x can be alone. Are we okay? So therefore, but this is an equation. What you do on the right hand side can be equivalent to what to the left hand side, right?
Yeah.
That is the same. That means what's on the right hand side can be what can be done on the what? On the left hand side as well. So therefore, if we divide this area by 2, so therefore here also is what is equal to what? Divided by 2, right?
Yeah.
So therefore this man and this one will cancel. Alright?
Yeah.
So therefore we now have what? X here is now equal to what do we have here now?
1.
Is 1. Are we getting this concept here?
Yes, sir.
So what happens now? What about multiplication? Sorry, addition and subtraction. They are also inverse. You know how they are inverse? Because we are going to collect like terms, right? Whenever you are asked to find a variable, that variable must stand alone. Are we okay?
Yes,
So in this case here, the next that you must do in an equation here is to collect like terms, right?
Yeah.
When you're collecting like terms, mind you, if this one is these things are so simple as this one, right? Are we okay with this?
Yes,
So in this case here, let's assume we have 2x here is equal to 8. Let me just put this one here. Minus 3 here is equal to 1. Observe something here. Now we want to achieve this guy, right? When is getting what to stand alone. So what do we do now? We reciprocate it, we transpose the term, right? But when you are transposing here, this man is dropping the equal sign. What happens now? This man is negative, right? Coming over here becomes what now?
Positive.
That's how they become inverse now. It was negative. Coming over becomes what now? Positive, right? So therefore, what happens now? We have what? 2x now is now equal to what we have here? 1, maintain that 1. Now, this man is coming over and it was negative now, becomes what? Positive. So you see how they are inverse, guys? Mind you, if this man was positive, when coming over it should become what? Negative. So that's how negative and what and plus and positive they are. That's how they are inverse. Are we getting this concept here? So that is all that we have to learn this particular session. So what next are we to look at again? We are going to look at all the types of an equation. Without knowing the types, how can you solve the problem? We are going to have linear equation, right? I'm going to solve problems on linear equation. All these are what they are linear equation. I'm going to skip linear equation. I will start to talk the simultaneous equation today. And maybe inshallah, we are going to complete simultaneous equation again. Both second variable, 2 variables and 1 and 3 variables, right? Hopefully, inshallah, we are going to complete them today. Alright? Because we have a bigger target. It's also say quadratic equation, alpha, beta, we are going to find them. We're going to look at after the class, we're going to set our timetable, right? How we can operate. So in that light, what are the types of an equation? We say we have to have linear equation, right?
Yes,
I'm going to skip that one. We have to have quadratic equation.
Yes.
We have polynomial equation, alright? We have the spherical equation as well. From your first CA, so that's one in the question paper, right?
Yeah.
I told you that is a spherical equation. But we're going to look at them all. Let me just explain what is a linear equation. A linear equation here is an equation where the highest power of the variable is equal to what? Is equal to 1. Alright? When you look at indices here, index means what to the power, right?
Yes, sir.
So in that light, if you look at this man, here we have what? You have x squared. Is that also, sir? That means the power is what? Is 2, right? But what am I saying here? That a linear equation here is an equation where we have the highest power of what? Of the variable. We know what is the variable, right?
Yes, sir.
That is why I explain what a variable is. Because when we go to these guys, we are able to look at their variables. Are we okay?
Yes,
Are we getting the concept here?
Yes,
simple and straightforward, right?
Yes.
Now, we say what? A linear equation is an equation where we have the highest power of the variable to be what? To be what, right?
Yes.
What's that? Now, if we have what? 2x plus 3 equal 0. What does that mean? What is this equation here? This equation is what? Is a linear equation. Why? Because all of the power here they are equal to what? Their highest power is 1, right?
Yeah.
All of them are their own. Whenever the number stands alone, the power is what is 1, right?
Yeah.
We are going to indicate that one. Just as whenever what? The variable stands alone, that variable has a coefficient of 44, right? Same as the power. So wherever you see an equation like this, what do you do? Just transpose, collect like terms, right?
Yeah.
That's all. So I'm not going to spend more time on this guy. So what is what? Quadratic equation. Look at what quad. Alright? This is not quadrilateral, but quadratic equation. And what is a quadratic equation here? A quadratic equation here is any equation where we have the highest power of the variable to be what? To be 2. Alright? That is, we have what? We have ax square plus what? Plus bx plus c. But in this case here, is this an equation? No. This is not an equation. Why? Because there is an absentee. What is that? The equal sign, right? The equal sign is absent. So whenever you see what, you see the operators, you see plus, you see minus, you see a variable and a constant, and you do not see the equal sign, that is called an expression. Alright? Expression here is what is different from also an equation. Okay? So to make this one become an equation, what do we do now? We say this one is equal to what? 0. We have an equation, right? Two mathematical expressions here separated by what? By an equal sign is called what? Is called an equation. Are we okay? Yeah. For an expression here, we only have what? We only have the operators, the variables, right? Nothing like an equal sign. Are we cool with this one? Are we getting the concept here? Simple, right? Sure. We move. Check that out. What happens now? Now, if you look at the guys, we have a power, right? There are so many powers. This man has a power. 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 But what are we looking at here? Look at the definition here. The highest power. The highest power is equal to what? It's equal to 2. But highest power of what? Of the variable, right? Now, this man is a variable. This man is also what? A variable. Let's assume we have what? We have x square plus what? Plus 2x plus 3 equal 0, right? Now, this one again is what? Is an equation. But what kind of equation is this? It's a quadratic equation. Why? Because this one has a point. This one is a variable. Is that also sad? This is a variable. Now, but the power of this variable is what? Is 1. Are you guys this is what? This is a linear equation because the highest power, because the power there is not is 1. No. What we are looking out for is what? Is the highest power. And what is the highest power here? The highest power here is what? Is 2. So wherever you see what the highest power to be 2, then that particular equation is called what is called a quadratic equation. Okay, sir? What do we do here? We have different ways by which you can solve quadratic equation. 1 is by what? Factorization method. 2, completing the square method. We also have what we call as what? As the formula method, right? And next we have what? We have the graphical method. Okay? But for this book here, which I showed to you guys, there's something like graphical method. But when I look at your slide, there's something like graphical method, right?
On a quadratic.
On a quadratic equation. A quadratic
graph for quadratic.
Yes, we have graph. We have the minimum curve. We also have the maximum curve as well. But we're going to look at them, right?
That's for those that are studying mathematics at Fabi College.
No, not also maybe College of Medicine. Alright? maybe it's going to be part of the exam, eh? So let's go. Now, if we are looking at this guy, this is just an explanation, we're going to look at them in detail, right? Now, let's leave polynomial equation. Let's look at simultaneous equation as well. It's not that type of equation. So what is a simultaneous equation here? A simultaneous equation, look at the word simultaneous, right? That means step by step. When you say simultaneous, it means we cannot solve them at the same time. It means you must look at one after the other. Alright? A simultaneous equation here is an equation where we have 2 or more unknown variables. I'm using 2 or more, right? Not only 2. If you look at the book here, we have you have more than what? More than 2 variables, right? You can see x, y, and z. I know you have used to solve problems on just 2 variables, right? But no, this you are university students, right? We have to extend the concept. So where we have 2 or more unknown variables, where is the set equation? That equation is called a simultaneous equation. What's that? If we have x plus y plus z is equal what? Let's say it's equal 9. Now how many variables are you seeing here? We have 3 variables, right? But we say this is what a simultaneous equation because you must solve for either x, z, or y first. After which you come for what? The balance 2. Alright? And solve for them as well. But if we have x, it can be what? M and N is equal to 10. It can be what? P plus what plus Q is equal to what? 0. It can be any letter. Alright? But just like that, wherever you have what? You have 2 unknown variables. or more unknown variable, that variable that is they are unknown, that is more than one, is called what? It's called a simultaneous equation, right? And we have methods of solving what simultaneous equation. Just two methods. What are they? We have the elimination method, and also we have the substitution method. What's the elimination method? Look at what eliminated. See, they have eliminated Barcelona, right? From the Champions League. So what does that mean? Are you part? So you move, right? To get rid of something. Now, if we are using the elimination method, you must look at for what? For a key value. Alright? That means it can be what? It can be X, it can also be what? It can also be Y, right? Look for that particular value and what? And eliminate that value, because you cannot solve for them at the same time, right?
Yes,
this is not quadratic equation. This is not linear equation. But it is what? A simultaneous equation, right? As the name implies.
Yes,
so we solve for them simultaneously, one after the other. Alright? So whenever you're using what? Elimination method, you must look out for what? For the signs. They are in this book, right?
Yes,
whenever the signs are the same, what do we do now? We subtract the values.
Yeah.
Alright? Whenever the signs are different, what do we do now? We add the values, right? Why? Because you want to eliminate. But when you look at the substitution method here, what happens now? You just make one of this guy the subject, right? Okay. And substitute it to what? So any of the question which you have what? Which has remained. Are we okay? Now, so let's take product and start with what? Let's start with elimination method. Or which one do you want to start with? Okay, let's start with elimination and go to what? Those values that we're going to use for the elimination method are the same values we're going to use for what? Substitution method. Are we okay? Yeah. So let's take problems and solve. Simple and straightforward, right?
I'm not catching. I mean, if I book.
Yeah, it's part of the book.
I mean, I'm not catching. I forget.
Whichever. Let's go. And also look for the past that book. Past question. The past question book. Let you can see past question book.
Wow.
You have it.
Oh yeah.
Let's go.
Solve the following.
Solution, right?
Yes, solve the following pair of simultaneous equations.
Yes, sir.
Using elimination.
Elimination method, yes, sir.
The first one, x plus y.
Now, one here we have what? Let me just. You have the x plus what?
Y.
We have x plus y
Equals to 3.
equal 3. I will call this one equation 1. Next,
4y plus 2x.
we have 4y plus what? Okay, 4y, right?
Plus 2x.
4y plus
2x.
2x is equal
Equation 2. 8.
8. Equal equation what? Equation 2, right?
Yeah.
Now, we have to look at what? We have to solve some what? Using what? Elimination method. Is that not so
Page. Which page?
Page. Look at the page.
How can we?
Okay. Now we go.
The first page. The first page.
Now, if you look at this guy, are you paying attention here? Yeah, what do you have here? X, right?
Yes, sir.
But whenever you are solving the problem, make sure you put it underneath, right? This X should be underneath this other one. Are we okay now?
Yeah.
So we rearrange. And how do you rearrange this guy? Just say X here plus what? Plus Y is now equal to what? Yeah? Now, this is the value of X. Is that also, sir? X should be underneath X. We have 2X here.
Plus 4.
And next one we have
Plus 4.
plus 4Y equal what? Constant,
Yeah.
So this is equation 1 and this is equation what? Equation 2. But we have to use what? Elimination method. Is that also, sir? That you can eliminate anyone. Anyone. You can eliminate X or you can eliminate Y. Which one do you want me to eliminate?
X.
X, right? Now how can you eliminate X here? Now, next step here, all of these steps are in that book, right? Now, let's look at this man. How many values do you have here? 1, right? So, how many values do you have here again? 2. So therefore, I will take this man here. Something like yours, you are cross multiplying, right?
Yeah.
So, if you have 1 here, multiply by what? By 1, eh? If you have, what do you have here? 1, eh? Multiply by 1, what do you have here now?
2.
So multiply by what? By 2. Are we okay?
Yes, sir.
So that's the case. What do you have here? 2 times x, what do you have?
2x.
Now we have 2x plus 2 times y, what do you have?
2y.
2y equal 2 times 3, what do you have? 6. This equation and this equation, are they the same?
No.
They're not the same. So let's call equation what? Equation 3, right?
Yeah.
Now, come on again. 1 times 2x, what do you have?
2x.
We have 2x here plus 1 times 4y. 4y equal 1 times 8. We have 8, eh? This is same as equation what? Equation 2, right? So next step here, continue with your box here. Now here, the signs are they the same? You have to eliminate x, right?
Yeah.
What is the sign here? Plus, and what is the sign here?
Positive.
Positive as well. So what do you do? Same sign, what do we do? Subtract,
Subtract, yes.
Good. Now, come here. You have 2x, subtract by what? By 2x. What's that?
0.
So therefore, this one here and this one here should work out, right? Now again, what do you have here? The coefficient is what is 2, right? If you have 2 minus 2, we say minus 4, what is that? That is minus what?
Minus 2y.
Minus 2y is
to minus
equal 6 minus 8, what is that?
Minus 2 as well.
Now we have minus 2 again, right?
Yeah.
Since we have an equal sign here, this negative and this negative we cancel, right?
Yeah.
We now have 2y here is now equal to 2 again.
Y.
Are we okay? So find the value of y, what do we do? Divide it by 2, here by 2. So these 2 and these 2 we cancel, and y is now equal to 1. So we have gotten the value of y, right?
Yeah.
Let's solve for x. Now, you can take any of the equation. Which equation do you want me to take? Second equation, right? What is that? We say from equation 2, from 2 we have 4y plus what? Plus 2x here is equal 8, This is equation 2. But already we have what? We have the value for y. And what is the value for y?
1.
1 plus 2x here is now equal 8, 4 times 1, 4 plus, here we have 2x is now equal 8. So let's collect like term, right? Make 2x the subject here, equal, over here what do we have? 8 transpose becomes negative 4, Now we have 2x here is now equal to what? 4, right? So find the value of x here, divide both sides by 2. So this and this we cancel, and x here is now equal to what? We have 2. So therefore, x is equal to y is equal 1, That's how we solve. I hope you're okay with this one, right?
Yes, sir.
You can solve the rest, is that also, sir?
Yes, sir.
Can you solve the rest?
Yeah.
When already are you?
We are long about to give away when I difficult.
Three things. Now, let's
Not difficult.
let's go to three variables now.
Let's first go to word
Problems, right?
Oh, okay, did it?
Yes, sir.
Well, the alphabet I make a be watching.
We do
No, we
step
see
by
third test.
step.
Now use for study for alphabet.
Let's go. Next problem. What problem,
Yes,
Let's go
one
what problem.
leading to
Those
something.
you can solve them. Yeah?
So the same,
Mm-hmm.
the sum of two numbers is 24.
Yes,
The
sir.
difference of this number is 12. What are the two numbers?
Come on.
It's
Simple
a
and straightforward.
problem. It's a- I like your opinion, that is,
Simple and straightforward. You understand, sir? Now, look at this one here. The sum of what?
two numbers.
Now, when you say sum in mathematics, it means you have to add, right?
Yes, sir.
Sum of two numbers. You know the numbers here? You don't know. You let. You can let any number. It can be x and y. It can be p and q. It can be m and n. It can be alpha and beta. Whatever the case may be.
Okay.
Are we okay?
Can be B and A, sir.
Any a and b.
Even C and B.
Of course. Let. What are we to use now?
I won't know
X.
that.
Let x and what? Let the number be here.
Yeah.
Let the number be. Let the number. The numbers NUM. Numbers be x and y,
Yes, sir.
Good. But what's happening now? The sum of these numbers, what are they? What's the value? That means x here plus y is now equal to what?
24.
24, Good. Call this equation 1. Next, what do we have?
You say the difference of these numbers is
The difference of this number, difference in mathematics means we have to subtract, right?
Yes, sir.
Now, we now say x here minus what? Y is now equal to what?
24.
24 times 4 again?
No, 12.
12,
The difference is 12.
Now we have what? We have equation what? Equation 2, right?
Yes, sir.
Now, look at this man, the coefficient is what is 1, right?
Yes, sir.
These guys, they are the same. If you apply the previous method here, if at all the guys are not the same, right? And you want to eliminate. Now, what do we have here? I will just go straight to the point. You have the book. Same sign, what do we have? Look at the sign here. If you want to eliminate y, the sign here is what is different, right?
Yes, sir.
But when you want to eliminate x here, look at this one. If you want to eliminate x here, the signs are they different, sir?
No.
No, they're the same, right? Same sign, what do we do? We subtract, right? So therefore, what happens now? Here, the signs are the same. So what do you do? We subtract here. Good. So what happens now? X minus x here. What do you have?
Zero.
This and this we cancel, right? And y here minus y. What do you have here?
Plus y minus y. 0.
Plus y is what?
0.
Yeah, is what?
0.
No, sir.
Okay, sorry. 2y.
Yeah. No, sir.
2y.
Minus times minus gives you what?
Plus.
Plus. Are we good now?
Yes, sir.
Good. So we have what? We have positive 2y equal 24. This is what negative, right? What do you have now?
12.
12, eh? So therefore, to find the value of this number here, what do we do? Divide both sides by 2, eh? And the y here is now equal to what?
6.
Are we okay? Now, take another equation. Which one are we to take? Huh?
Equation 1.
Equation 1. From equation 1, eh? We say from 1 here, we have what? We have x plus y is now equal 24, eh? And now we have what? We have x and we know the value of y, which is 6, eh? Equal 24. So therefore, x here is now equal to 24 minus what? Minus 6, eh? So x now is equal, and
18.
what do we have here?
18.
We have 18. So therefore, the two numbers are what? 18 and what? And 6.
16 and 6.
So when you substitute the value here, 18 plus 6, what do you have?
24.
24. Alright? And 18 minus 6, what do you have? Are we okay?
Yeah.
Good. Let me just use the substitution method to solve this one again. Let me just use the substitution method.
Yeah, I get you. Yeah.
So we have what?
What do you?
X plus y is now equal to what? 24, eh? Now we have what? We have x minus y is equal to what?
What is it?
12, eh?
Yeah.
So, from this point here, make x of the subject.
Yeah.
We now say x here from 1. X is now equal 24 minus y. Is that also, sir? We can call this equation 3. Now we have what? We have x from equation 2 now. We say we have x, right? But what's the value of x now? 24 minus y. Now we have what? We have minus y again, eh?
Yeah.
Equal what? 12. Is that also, sir?
Yeah.
Is this one okay here?
Yeah.
Yeah. Now, 24 here minus y. Is that also, sir?
Yeah.
Good. Now we have what? 24 here, minus times minus here, what do you have? Plus, right? But we have what? Minus what? 2y here is now equal 12, eh? We want to find the value of y. So what do we do now? We can now see this is 24 minus 12 here must be equal to transpose this one becomes what? Positive 2y, eh? And 24 here minus 12, what is that? 4 minus 2, what is that?
12.
4 minus 2, what do you have?
4 minus 12 is 12.
24 minus 12, what is that? 12, right?
Yeah.
Good. This one is equal to what? 2y, eh? So find the value of y by both sides by what? By 2. This and this we cancel. And y here is now equal to what? 6. We end up having the same answer. Are we okay? Take another equation, substitute to what is another equation again. What's that? Look at equation 3.
Yeah.
From 3 here we have what? We have x is equal to what? 24 minus y. What is y? 6. So when you subtract, you have the same answer.
15.
Are we okay?
Yeah.
Now the sum of the two numbers, yeah?
60.
Now let the numbers be. This time I will say what? M and N. Yes, sir. The sum of two numbers is what?
60.
Now M here plus what? Plus N is now equal 60, right? Call this equation 1.
And the difference is 3 times the first number. And
Look at
the second.
difference means what? We have to subtract, right?
Yes.
But 3 times what?
The first number.
First number. What's the first number here?
It's M.
Now 3 times M gives you what?
Yeah.
3M. And have you got to take a step now? It's what? What do you have? It's
Then-
what?
Then they say, and the second is 40.
It's 40. This one is equation what? Equation 2, right?
Yeah, they say find the numbers.
Find the numbers. So we have to find the numbers, right? Now you can use elimination method. Well, let me use substitution method for now, right? From equation 1. Start by saying from 1. From 1, what do you have? Make n the subject, right? Or you make m the subject. Which one do you want me to make the subject? N. So therefore we can say n here is now equal. What do you have over here? 60, right? Because we have m here and this m is positive, going over becomes what now? Negative, right? Let's say minus what? Minus m, eh?
Yeah.
Call this equation what? Equation 3. Are we getting the concept here? Good. Now, take equation 3 and substitute into what? Into equation 2. Are we okay?
Okay.
So we go. We now say this is what? 3m minus n. Already we have a value for n, right? And what is that? 60 here minus what? Minus n. Are we okay?
Yes, sir.
Good. So therefore, let me just put this one into brackets. Why? Because the sign here is what is negative, right?
Yes, sir.
And the sign here is also negative. So what you must do here, put them into brackets. So that you can multiply, right? Because the sign there, they're the same. Why? This is negative and this is negative. But let's assume it was plus. Here is plus and here is plus. Just leave it as it is. Are we okay? So we go. This man is equal to what? 40. You come again and say, well, this is 3m here, plus times minus here. What is that? Now we have what? We have minus what? Minus 60, right?
Yes, sir.
And minus times minus gives you plus, plus what? Plus m here, we have what? We have 40. Are we okay?
Yes, sir.
Good. Now, let's collect like terms now. You have 3m here and then you have m. What is that now? You get 4m here. Next, we have equal sign here. We have 40. And this is negative 60. Going over becomes so positive now, right?
Yes, sir.
We have what? Plus what? Plus 60. So we have 4m here is now equal to what we have here now? 100, right?
Yes, sir.
Good. So divide both sides by what?
4.
By 4 and here by what? By 4. So m here is now equal 100 divided by 4. What is that? What's that?
It's 40. So 40.
Huh?
25.
Okay, so it's 25, right?
Yes, sir.
1 divided by 4 is what is 25. Next, what you want is n, right?
Yes,
So
sir.
n here is now equal 60 here minus what? Minus m. What is m now?
It's 25.
N is now equal to what do you have here now?
N is 35.
Now we have 35, eh?
Yes, sir.
So therefore, the two numbers are what? 35 and what? 25, right?
25, yeah.
That's all. Next problem.
The same.
In front of you.
Oh,
Yeah?
X minus 2y
X minus 2y
minus 2z
minus 2z
equals 0.
equals 0. Yes?
2x plus 3y
2x plus 3y
plus z
plus z
equal 1.
equal 1.
And then x, you say 3x
Now you have 3x
minus y
minus y
minus 3z
minus 3z
equals to 3.
equal 3. So you can tell that we have 3 equations, right?
yeah.
And they are simple as 3 equations. They are also, sir.
Yeah. No long problem.
So let's go, right? So looking at equation 1 here. Say from 1, eh?
Yes,
So
sir.
now what x here is now equal to, over here, what do you have? 0, eh?
Yes, sir.
So it transpose everything. So we now have what? 2y. Next, what do we have? We have minus 2z, right?
Yes, sir.
Now we have what? We have plus 2z now. Call it equation what? Equation 4 now. We have three
Four,
equations.
yeah.
This is equation 1, equation 2, and equation 4. Are we right?
Yes, sir.
Good. Now, looking at this guy here, equation 2 now. What do you have for equation 2? You have 2x, right?
Yes, sir.
Good. So when we have the value of x now, I will come down and substitute the value of x into equation 2. Are we okay, sir?
Yeah.
Simple and straightforward, right? I am using what the substitution method. So we have what? We have 2x. But what is the value of x now? Is 2y here
Plus 2z.
plus 2z plus next what we have? 3y, eh?
Yes, sir.
Plus z here is equal to what? 1. Are we alright?
Yes, sir.
Now we multiply now. 2 times 2 what do we have?
4y.
We have 4y plus 2 times 2 again.
2x.
We have
4x.
4x here. Plus 3y plus z is now
Plus
equal 1, eh?
Yes, sir.
Let's collect like terms now. Now what do you have here?
4y.
Sorry. What do you have here? Here is z, eh?
Yes, sir.
So here we have what? We have z.
Yes.
Z. So here is also what? Z, eh?
Yes, 4z.
Good. So therefore collect like terms. 4y plus 3y. What is that?
7y.
We have 7y plus 4z plus z. What is that?
5z.
We now have what? 5z
Z.
equal what?
1.
1, eh? Call this equation what?
5.
Equation 5. The target here is for you to have what? For you to have two unknowns.
2 unknowns.
Are we okay, sir?
Yes, sir.
So we go. Now take this same equation 3 here and it's equation 4 and substitute into what? Into equation 3.
Equation 3.
Are we okay?
Yes, sir.
There we go. We say this is 3 into x, but we already know the value of x, right?
Yes, sir.
2y plus 2z.
2z.
Okay?
Yes, sir.
Now minus y minus 3.
3z.
Z is now equal
3.
3. 3 times 2, what do you have?
6y.
6y plus 3 times 2 again.
6z.
6z minus y minus 3. Z equal
3.
3. Now, let us collect like time again.
Yes, sir.
6 minus y,
5y.
what's that?
5y.
You now have what? 5y.
Mm-hmm.
Next you have 6z minus 3z, and what is that?
It's 3z.
Plus 3z. Must be equal what? 3, eh?
Mm-hmm.
Call this equation what?
6.
Equation 6. Now if you look at the equation now here, equation 5 and equation 6 here, they all have what? Both of them have what? 2 unknown, right?
Yes, sir.
And what are the unknown here? X and what? Sorry, y and z, y and what and z. So it means now you have arrived at our previous system, right? What's that? What was the system? 2 unknown, right?
2 unknown, yeah.
Good. So therefore, take equation 5 and equation 6. Solve them simultaneously now.
Yes, sir.
Are we okay?
Yeah.
You now have what? 7y
Yeah.
plus 5z equal 1, eh?
Mm-hmm.
And here we have what? We have 5y plus what? Plus 3z equal 3. But if you observe here, let us use elimination method here. Now, for you to use elimination method here, it means you must get rid of one of the variable, right?
Yes, sir.
Either x, sorry, either y or z.
Mm-hmm.
So that light. Which of you want me to get rid of here?
Why?
Why? But this guy and this guy are they the same?
No.
No. Let's try to make them the same, right?
Yes, sir.
So how can you obtain that one here? So here, look at this man, your box, and here what do you have here? 7, right?
Yes, sir.
Just assume that you are cross multiplying here.
Yeah.
Here is 5, multiply by what? By 5.
Yeah.
Okay? Here is 7, multiply by what? By 7. Okay?
Yes, sir.
Now let's multiply. 5 times 7, what do you have?
35y.
You have 35y plus 5 times 5, what is that?
25z.
25z
Equal
equal
to
5
1.
times 1
It's 1.
is 5.
It's 5, sorry.
Okay? 7 times 5 is what?
35.
35 again. Y plus 7 times 3 was that?
21z.
21z is now equal to 7 times 3 again?
3.
21.
21.
Are we okay?
Okay.
So in this case now, at least we have one value which you can get rid of, right?
Yes, sir.
Good. So since the sign are the same here, what do we do? Subtract, eh?
Yeah.
Now 35y minus 35y, what is that?
0.
0, eh?
Plus.
Now come here again. 25 minus 21, or what is that?
It's 1. It's 4.
4z is now equal, and 5 here minus 21, and what is that again?
It's
Huh?
17.
7? No, not 17 here. 21 minus 5, what is that?
21 minus 5?
Yes, sir. Look at this one here. You have 21, right?
Yes.
Minus 5, what is that?
It's 16.
16. Are you okay now?
Yeah.
Good. Now we have 16 here, but negative 16, right? Because bigger number carries the sign.
Same, yeah.
So, to find the value of 4 of this guy, divide both sides by what? Say 4z here divided by what? By 4 equal minus 16z. Here is also what? Here is 16z, right?
Yes, sir.
All upon what? All upon 4. This and this we cancel, and z here
equals
is
to
now equal
minus
to what? Minus what?
4.
Minus 4. Are we okay?
Yes, sir.
Good. We have gotten the value of what of z. Let's set the value of y. Taking of the equation. Which one? Which one do you want to take?
Let me say equation 6.
Equation 6, right? What's that?
5y plus 3.
Now we have 5y. Now, what is y now?
It's 4.
Okay,
Minus
now,
4.
okay, 5y here plus what? 3z. What is z? Minus 4, right?
Yes, sir.
Equal 3, eh?
Yeah.
Now you have 5y here plus times minus
Minus.
3 times 4, 12, eh? Good. You now have what? 5y is now equal 3 here plus what? Plus 12, eh?
Yes.
Now we have 5y here is now equal 3 plus what is that?
15.
15. To find the value of y, we divide both sides by what? By 5, eh? Yeah, by 5. And y here is now equal
3.
3. So simple it is, right?
Yes, sir.
We are going to the value of z and y, right?
Yes, sir.
Now come to equation 3. What do we have here? We have x, eh?
Yes.
sir.
X is equal to what? 2y plus 1 plus 2z. Is that also, sir? Let me just attach this guy here. We have x here is now equal to y. What is y now? What is y? Y is 3, right? Plus 2z. And what is z?
Minus 4.
Minus 4. This one is equal to what?
0.
Okay, just that. Now we have x here is now equal to 2 times 3, 6 plus times minus 2 times 4, 8, eh? Are we okay?
Yeah.
This one is equal to, and
Minus
6
2.
minus 8, what is that now?
Minus 2.
Minus 2. Therefore, x is equal minus 2, y is equal, what therefore y? 3, and z is equal what?
4.
4.
Minus 4.